Hello, my name is Sacha Faust. I'm part of the Cloud and Enterprise Red Team at Microsoft. Been there for a number of years. And I'm co-presenting with Andrew Johnson, who's also part of the Azure Red Team, or what we used to be called Azure Red Team. Now I got to change the wording in Cloud and Enterprise. We sort of expanded a little bit. So we'll be talking today about cloud post-exploitation. For obvious reason, we can't really provide info in terms of how to do the initial break-in, but we'll provide some pivoting opportunities and kind of explain, provide an overview of the cloud. So a couple of takeaways here is kind of a quick crash course on Azure and cloud overall. Obviously, we can't really go in detail in AWS or what Google has and so on. We're focusing on our Azure, and we're sort of giving an open invitation moving forward to the other cloud providers to come and share what they've learned. So we'll provide cloud pivoting trends, blue trends that we're seeing in terms of detection, what is really making our life a little bit harder and from a red team perspective, and some countermeasures. Quick overview of our red team, which a lot of people are asking me, hey, I'd like to start a red team. Can you come and do find exploits or cross-site scripting and so on? That's really not what we do in our red teams. So I wanted to give kind of a quick overview of some of our focus. So our measure of success in red team is mean time to compromise and objective up, mean time to detect and recover down. Those are our sort of guiding light or lighthouse. Red team is a lot of uncharted territory. These are sort of our compass. So anytime we make mean time to compromise and objective up, I think we're driving change. Obviously, we have dual mind where we think offense a lot. So for us, we want to reduce mean time to compromise, reduce mean time to objective, and that puts pressure on the rest of the org to actually make it harder for us. We have clear rules of engagement. It's pretty clear what we can and cannot do. We're P0 focused, meaning disaster scenarios, where we sort of say, okay, this is game over, we're kind of screwed. So we really force those functions in. We're cloud vs cloud, meaning that the amount of resource in terms of compute and so on that are available to us is a little bit unique. We have pretty much unlimited access to our cloud infrastructure, so if we want to do things at scale, we definitely can. And we're sort of shifting our mindset gradually from operation to recovery games. If you assume breach, you should recover, therefore let's force you to recover and let's start measuring. Service availability is already thinking that way. Azure has I believe 99.9 or 99.95% availability. The engineering has to understand how to drive this. So we're kind of taking lessons there and applying it to security. From a culture perspective, a really collective growth mindset. Let's make it harder. Just finding number of bugs and so on is really not that interesting for us. We really want to push the needle. We're very engineering focused. Microsoft is at the core an engineering company. Our problem is scale. The core problem that we have is scale in terms of the playground is really big. So we're very engineering driven, also very diplomatic. We're not telling you what to do, we're just kind of sharing our learnings. So we let the rest of the org kind of drive enforcements there. Our role is really to influence, not telling you what to do. And we're trying to move and operate like next generation APT. We'll give you a little bit more detail there. We shared some of that in 2015 at Infiltrate, with the data-driven offense approach that we've disclosed. And to some case, we're starting to think about purple. We're very purple mindset. At the end of the day, you have to help the blue teamer if you want to push the needle. So we're leveraging, and at the core, the red, but we also have kind of a blue side to us as well. So that's it in terms of the team's introduction. I'll let Andrew kind of give you a very quick crash course on Azure.
Thank you. So there's a quick crash course on Azure, not really how to set up a VM, but what you need to know to attack it. And I'm going to draw a lot of parallels to way services were run before the cloud. So a super simple diagram, if you were running a production domain in a data center, you were running a service, it might look something like this, especially if it was a Windows-based service. So you had your own private network. You monitored all of the ACLs. You had ingress and egress monitoring, and everything was a machine. Everything was an operating system. You had file servers, application servers, and they were all connected to some root of trust. In Microsoft's case, that's obviously Active Directory, and that ran the service. And you pretty much had full control over each of those pieces. In the cloud, it's very different. If everything is connected to the cloud, and nothing is just a machine. Sure, you can just have a VM up and running in the cloud, but if you're actually scaling your service to cloud scale, then you really shift from everything as a machine to everything as a service. So where you used to have a SQL server before, or a set of SQL servers, you now use SQL Azure as a service. Where you used to have storage before, and file servers and massive SAN arrays, now you have Azure Storage or other blob storage providers. So instead of everything being internally and having its own root of trust, it's now all connected to the cloud, and it's all public. So we really call this the cloud mindset, and we can actually draw quite a few parallels in attacking from what we used to do in a domain-based system into the cloud system, as long as you shift your mindset a little bit. So instead of thinking about servers, you now think about services. If you are attacking a service in Azure, you're going to be going after that services that they use in Azure. So for attackers, that really means that the domain has now become the subscription. So when you set up your cloud subscription, you have identities that can run that subscription. So those identities have now become the domain admin. So if normally you would breach into a data center or a network that was running something, you would now breach the identities of that subscription admin. Because the cloud isn't running in a domain, there is still sort of this domain concept around subscription admins. And so that means that our attacks change quite a little bit as well. So pass the hash has now become the credential pivot. I mean, pass the hash worked so well because in that domain environment, there were only a handful of auth mechanisms. You either had your NTLM keys or maybe a Kerberos ticket, and you could pass those along. In the cloud, there's many types of keys. So now you have storage account keys, SQL connection strings. Almost each one of those services has its own type of key. And so it becomes collecting those which actually give you access to what you need. If you really think about it, when you're attacking a cloud service, you're really going after the customer data, and that's rarely sitting on a VM. So in the production domain, you would just hit the file service. You could probably get most of the information you needed, or hit the SQL box. In the cloud world, you're going to actually need to hit those individual services. Everything is running on public IP addresses. This is one of the staples of the clouds. Now there can be all sorts of fancy network rules and firewalls in place, but in the end, those services are publicly accessible. And the management has changed quite a bit as well. So in the domain environment, whether you're running Windows or Linux, you're going to be doing a lot of RDP and SSH. Now that kind of turns into management APIs. So the cloud has a set of APIs that lets you manage all those assets and do the same type of tasks that a domain admin would do back in a production domain. So that was our really quick crash course into what you really need to know. Now we're going to try and talk about a couple pivots that are not really new to the world, but have been adapted from old style thinking into the cloud. So here, like we showed before in 2015, and if you're attacking a domain, you're certainly using some of the newer graph systems out there. So we represent everything in terms of a graph. So if you have a subscription and you have either access to that subscription or access to one of the storage accounts in that subscription. Someone leaks some credentials, and now you have a storage account. In Azure, IaaS VMs, so individual VMs, store their hard drives in the storage system. So if you have access to that storage system, either because you're the subscription admin or you have the storage account, you have access to that VM. And you can get that by either just downloading the VM, which will probably actually give you everything you need. Like I said, in the cloud world, VMs aren't as important. They're not storing their data locally. They're storing them in some other type of service. So you can easily just start Azure Storage Blob Copy, download that VHD, open it up, extract anything out of it that you need. If you do need to actually get on to the VM, you can wait until that VM has been turned off. The blob actually gets locked while it's on. And then you can replace the VHD. So you can download it, make any modifications, install anything that you need, put the VHD back into storage. Next time the VM boots, you'll get your code running. We do currently have an open research area where we think we might be able to get tamper with a running VM, but haven't fully gotten that working yet. So this is one pivot that we want to show of something slightly new that exists in the cloud, but how once you've got some of these cloud assets, you can go and pivot onto something else. So just as any service, any website, anything hosted on the internet needs to be able to bootstrap itself when it spins up. In the cloud world, that is called PaaS. So PaaS is Platform as a Service. So you can think of it as IaaS as a service if you were running a website, or any of the other platforms that you'd run your website on. Now, from an attacker's perspective, the interesting thing is these things have to be able to scale. That's the whole point. So as your site gets more and more traffic, or your service needs to scale, it will scale itself out onto more and more VMs and set up all the routing, all the load balancer, and everything for you. From an attacker's perspective, that means that this PaaS instance, this PaaS service, needs to have everything it needs to bootstrap new VMs, which means that it has all of the credentials it needs for the service to run. So in the Azure world, we call these cloud services, and they're made up of three parts. There's a certificate store that's actually part of the service. There's a package, that's your code. So you deploy the new package to the service, and you deploy a configuration file. So if you're from the ASP.NET land, this would just be your code and your web config file, and then it also has this extra certificates thing on it. So if you have compromised a subscription, then you're usually wanting to get at some of those credentials that the PaaS service is providing. So here's our graph of what that is. To actually deploy a package in Azure, it does already need to deploy a package to PaaS. It already needs to be in storage. So if you have access to that storage account, then you can package these things up. And then there's a couple little nuances. The hosted service can have many different roles. There might be an application role, or a database role, or an authentication role, and those are all inside the hosted service. And those roles actually have the VMs. So each role has a set of identical VMs hosting the same content, and of course they can be part of a network security group as well. So let's talk about some attacks against PaaS services. Well, the first one, again, is pretty simple. There is something called an RDP extension that allows you to debug these PaaS instances. So to get that RDP extension running, you need to call get Azure deployment. You just create a new Azure remote desktop extension config. And actually, when you run the get Azure deployment, you'll get the full configuration file that this PaaS is running on anyway. In the new Azure configuration, the extension configuration, you set the username and password, and then you push it as set Azure deployment, and when you're done, you can remove that. But during step 3, it's actually going to create new admins on all of the VMs and open up RDP for you. Now, there's a couple little tricks that people can do to block this, but for the most part, that's going to work. It is a little bit noisy as it's adding new admins to the VMs, but if you have subscription access, which is sort of the same as domain admin, then you can easily get access to the resources that are running the service. So the next pivot that we talk about is really one that we use quite often in our red team engagements, and that's going after those certificates that the that the cloud service has. Now, these are either SSL certificates or encryption certificates, so you might have already breached the storage account, but now you need to get the encryption certificate to be able to decrypt the things in the storage account. So you can think of this attack as Mimikatz crypto export, where it patches the crypto API and exports all the certificates out of Windows. This is the same thing, just doing it for PaaS. So the key here is that there is slots in PaaS. So as you are building your service, you want to rev your code, you deploy it to something called the staging slot, and you verify that the code's up and running, you get the service all warmed up, and then you flip it over. So the production slot becomes the staging slot becomes the production slot. So what we're going to do is just use the staging slot. Now, we're never actually going to override the production slot, or else the service is going to probably go down, and the attack is going to get noticed. But you can query to get the deployment. That will tell you what all the slots are doing. And then you can just create your custom code package. So it doesn't have to have anything to do with the service that you're trying to attack. You just create a custom one. You figure out all the thumbprints of the certificates that you want to do, and then deploy that package into the staging slot. Now, what that does during deployment is it actually adds the certificates from the service certificate store onto all of the VMs. You have your code that initiates some type of malware, dumps those certificates out somewhere else. So then you can just wait for these certificates and use those to pivot to other places. So if one of those certificates was a management certificate for another subscription, you've now been able to hop from one subscription to another one. So now you're DA on that new subscription. So we have a little demo here of us doing this. I do apologize. We had to cut out lots of this demo to make it public, but this is a tool that's just going to call the APIs required to do this. So the service that we're going after is called Attack Gen Test. And here, this is just Azure Management Studio. It just shows you things that are going on in your subscription. You can see that there was a storage account there that didn't have anything in it, and here are the certificates that we want to go after. So we just run this, and we had to blur out a whole bunch of things here, not to show you what it was actually doing, but because it actually leaks a lot of creds in our output. So what that's doing is building this new basic package and deploying it into the cloud service. Now, when that package boots, it's going to load our malware, it's going to dump the certificates, and put them into that storage account. So here you can see it. There's two different deployments running in this cloud service. The top one was the previous service there that was called diagnostics role. So that's the production deployment. And that's what's actually hosting all of the live traffic. And then we just deployed into their service, into our breach subscription, we deployed into the staging deployment. Now we just wait for our VMs to spin up. As soon as they spin up, it's going to start that malware and dump out all the certificates that we need. So this isn't really a crazy new idea. People have been doing build system attacks and deployment attacks for a while. This is just how, if you think of the cloud as an operating system, this is just how one of the ways that you can get the certificates out. So now the deployment has finished, and if we now refresh our storage account, we've been able to extract all of those certificates out of the cloud service. So that's was just a really quick demo trying to show some of the things that we do, especially around getting these certificates. If this was a website or that was hosting traffic, those certificates would probably include the SSL cert that we would need to start man in the middling traffic to that service. And so along those same lines, if you actually want, instead of just getting the certificates out of the hosted service, maybe we do need to actually RCE the service. So again, if you have access to either the subscription or in this case, the storage account, then you can actually RCE the service by mostly the exact same way. So what we need to do is, instead of going after the staging slot this time, we're actually going to grab the production deployment. So the actual code that's running live in the cloud. We can do that by calling get package. That will put it into a storage account, and we can just download that package from the storage account. Inside that package is all the code. We just find an elevated task that we can use to bootstrap our malware. You can actually create one. It's just a lot more complicated. The packages do have file hashing. They do not have any type of signing, so they just have file hashing for integrity. So update all the file hashes inside of this package, and then actually redeploy the production service. As you redeploy the service, as long as you do it with the upgrade flag, it actually doesn't create new VMs or throw anything away. It just tells each VM to start running a different version of the code, which means that you're not going to have any downtime in the service. So as soon as your code bootstraps your malware, and now you actually have RCE on all of the VMs doing it. Depending on which service you're going after, could be thousands of VMs running that service, so make sure that your malware can actually handle that amount of callbacks. The last one that we'll really talk about is sort of the hybrid pivot. In the end, these identities that people are using for the cloud can exist in many different places. You could have, be it your Hotmail account, or you can actually use, Azure Active Directory and link it back to your on-prem directory. So if you are attacking someone that has an on-prem domain, then if you can get those identities that are used to do the subscription, then you can then pivot into the subscription. So the two graphs meet at many different places, what is actually available in the cloud and what their domain infrastructure actually looks like. So we just want to point out that these exist. There's certainly other pivot opportunities, especially in the hybrid case. Some people have actually linked their networks into Azure, so you can ride that network traffic directly in. But those are the pivots that we wanted to talk about. Now Sacha is going to come up and talk a little bit about persistence once you've been able to actually compromise the service.
Good. So we do have plans to release code. There's some complication there where we can't just release the attack code. We have to release kind of a purple package. So expect some code release coming up from our team, hopefully this year. I'm pushing pretty hard on it. In terms of persistence, we've seen a couple of pivoting. We kept it fairly simple, but kind of highlighted some of the pivoting opportunities that we have found. There's obviously a lot more. We'll gradually kind of start releasing them. So in terms of persistence, it's pretty basic. Hopefully the pyramid kind of represents the impact. Obviously, if you have compromised the identity, you kind of have everything below and so on and so forth. So subscription would give you storage account gives you cloud service, and so on. So we wanted to highlight a few areas where we have persisted in the past. So in terms of identity, these are service principals. So service principal support multiple password. So think about primary key, secondary key, or primary credential, secondary credential, and actually third, fourth, fifth, sixth one. So you can always add creds in there in the service principal world and start adding credentials that they may or may not be aware of. Also, monitoring on those service principal is key, but we're obviously not necessarily seeing this across the board. So simple persistence, add an additional password to the identity. There's also plenty other type of persistence at identity level. Basically, application provides a lot of options. Think about email with forwarding rules and so on. So I think the crowd is very well aware about some of those. you can definitely do that in identity in the cloud. Subscription, Andrew mentioned that the subscription is the equivalent of a domain. So, in your domain, you add domain administrator or domain administrator through proxying and so on. The same tactic that you may have used in domain infrastructure will work in Azure or globally in the cloud. So adding subscription administrator, management certificates, and so on, definitely areas where you can persist. They do support multiple subscription certificates, so again, you can add multiple ones as well. Storage account, they have storage account keys. We have plenty of those out there. I look at GitHub, for example. There's been plenty of cases where cloud credentials have been leaked through GitHub check-ins. Basically, there's plenty out there. So storage account, looking at a secondary key, for example, might be useful. Leave the primary key intact, use a secondary key, and they'll find out whenever they roll over the creds, which they may or may not be doing. Secure access URL, SAS keys, these can be minted offline. They're actually pretty useful. It gives you generate a key to access a given resource. You can mint them offline using the primary or secondary storage key. Those are become pretty useful because you create them at will. There's some tracking of it, but not much. And again, there's no sort of service interaction to create them. You can mint them offline and then use them at will. Cloud service, you can, as we described, tamper the deployment. So you can booby trap package and so on. These are software release pipelines type of attack where integrity checking may or may not be present, may or may not be looked at. So there's plenty of surface there. Virtual machine, I think you guys are very aware about various persistence mechanism at the virtual machine. So OS persistence, both on Windows and Linux, we support both in our cloud. So you can override the VMs, you can do shadow copy. Shadow copying is basically copying a VM while it's running. So Azure does provide you that capability, which means that whenever, for example, you can create a SAS URL for a storage account and you use it once in a while just to pull the VM down, look at what they've been doing, get the creds and use it for something else. Credential reuse could be something that might help you moving forward. At the network level, you can add resources or modify network security group. So we did display network security group in the graph earlier, where some resources may be locked down behind network security group. So even though there's no attack surface or management port, for example, on the virtual machine, through the deployment trick that we show, you will be able to reach those machines and inherit the network group permissions. So that allows you to actually pivot left and right within resources that will not be in reach directly through internet. So that has been kind of an interesting thing where maybe you could create your own virtual machine, add it to the network security group, and nobody noticed. So nothing is intact, nothing is detected, and when you publish your own package or virtual machine, you control whatever monitoring is on those for the most part. Moving forward, so as a business holder, do you really have the right visibility of the security risk? This is really not the conference for that slide, so we'll bore you to death there. So let's think more about from an offense perspective, and I kind of did a switch on that slide, is as an operator, are you aware about some of the detection mechanism available that may or may not catch you? So we'll dive into indicators of monitoring, indicators of detection. I would love to dive into indicators of recovery, but for obvious reason, I can't dive into that. We did present some of it. Go back to data-driven offense. We actually go a little bit more in depth there. So what I'm basically, the intent of this content is more about sharing some of the trends that we're seeing on the market and some of the things that are really making our life a little bit harder, which is good, but some of them are giving us some good head scratching. So the rise of anomaly detection, this is becoming kind of a buzzword, but beyond the buzzword, in the field, this is causing us some pain. Like we're starting to get caught in areas that we haven't got caught before. And when we start talking about blue team, they're like, oh, okay, this is great, the algorithms are working. It's that we don't know specifically what we caught, but we know we caught you doing something that was abnormal to the system. So this is kind of starting to get a little bit challenging. So there's the Twitter, basically, anomaly detection R package. We're seeing this trend left and right in the industry. There's the Google partnership with Tatvik as well. I hope that was Google. Maybe it could be AWS, but I believe it was Google. And obviously, we're seeing this in Azure Security Center, which has been catching us more and more, I would say, the last year or so, where we're starting to seeing anomalous logon from untrusted location, SSH traffic of machines that we've never seen before, and so on. And they're also being released as an API, so it's an open platform. Blue teamers or purple teamers can start looking at this, or even from an attacker perspective, you can start leveraging this and see, okay, they're on to me, because I'm starting to see connectivity that normally I haven't seen. So that's been kind of interesting, really kind of a pain in the butt lately, which is a good challenge. We want to make it harder and harder, so these things are happening. From a communication perspective, it's also interesting. Blue team and red team used to work in isolation. There's this concept of purple teaming, which I've dived into a little bit more on a presentation I did this year called Scaling Red Team, where I dive a little bit more in terms of I've shared a little bit my purple mindset there. But the reality is the blue teamer or red teamers are starting to talk more and more. So some of you may have seen this in the sort of public sector, but I would say private sector, it's starting to happen. And the mindset are starting to be shared as well. So traditionally, red teamers or attackers are thinking in graph, and blue teamers are thinking in lists. I personally think list thinking is very inefficient. It doesn't work with my personal wiring. So I've always seen things in pictures in my head, so graph was kind of illogical. So what we're seeing with the purple teaming is the graph thinking is there, the sharing is there. Overall, we're starting to develop a communication platform in a formalized way that could be peer-reviewed. So there's no longer just kind of a narrative and kind of cross your finger, hope that the audience is understanding. We're starting to look at the same infrastructure together, and we're starting to play games together using the same platform. So it's getting really interesting, and we're seeing advancements there. We're definitely benefiting from that. A good example, and this is a team that's been on the receiving end of good red teaming. And again, red teaming is not just app-level bugs. It's set an objective and figure out a way to get there. It could be through software, it could be social engineering, it could be physical, or in some case, you use leaning tactics, which obviously in the corporate world we can't do. So there's a good presentation there on Office 365 security in terms of how do they leverage graph approach to start doing really interesting detection. That team is starting to get really good in catching red teams. I know for a fact that they've survived internally found vulnerabilities within minutes. They've detected, oh, something anomalous happened, right away take the secure, basically the safe route and disable certain things. So very interesting presentation. There's a YouTube and a blog post on that. Threat intel is being commoditized. We're starting to talk more. The private sector is starting to catch up a little bit more versus the public sector has already been doing this for quite some time. So we're seeing IBM kind of talking about it. We're seeing Threat Exchange, which I think was a very good initiative from Facebook. We kind of followed a little bit with Microsoft Interflow. But we're also moving this to customers. So now, for example, if we take Azure Security Center, it's starting to correlate these things and start publishing this back or alerting back to customers. So this is starting to get interesting. And again, it's catching us. So if it's catching us, it should be catching most of the attackers. Obviously, use stealth and so on. But it's starting to get a little bit harder. So we're seeing here network communication with a malicious machine detected and so on. There's another interesting, I believe it was last year, there was a presentation on Infiltrate that kind of highlights the fact that offense is using stealth, but defense is visible. If you see all the defense, you can just turn it off, right? We're starting to see a trend of stealth being used for defense. So we had good feedback during the initial run with the Infiltrate team, the conference team, and they kind of gave us a good pointer there. So if you think about the data plane, which is the VMs and the storage and the services, you can go and compromise those services or those VMs, and you can disable certain things and so on and so forth. So you can do kind of OS-based avoidance or evasions and so on. There's plenty of tricks out there. This is a conference that's mostly focused on those. But when we start looking at the control plane, we start having access, a little bit more access to data. in a quote-unquote stealth fashion. So if you have a virtual machine and you've done all your stealth techniques and so on, great, you're bypassing OS, that's fine. But when you start looking at the OS at scale, at the core, at the raw VHD level, in the control plane, we can start detecting a bunch of stuff that, and you don't know any of the defense. So we're not talking about antivirus here that you can turn off. We're not talking about necessarily network detection that you could see, or let's say you land on the machine and you see 6 agents, 6 security agents, and you sort of laugh. You say, okay, I'll disable all of them, or none of them are effective. Now we're moving in the control plane where it's completely hidden from you. So watch out when you move forward is if you have indicators of monitoring and detection, you start taking notes because these things are changing quite a bit. I'm personally seeing kind of a trend also from an engineering perspective. I can talk from Microsoft, but I talk with quite a bit of companies out there, and I'm seeing sort of the same trend. One is obviously monoculture, which means that the infrastructure looks the same everywhere. That speeds things up, less complexity, more of a scale problem, but kind of the baseline is pretty much the same across the board, so that really helps. Shift from a cost center to a profit center. Security is a big thing in the cloud. So I would say the engineering investments are moving to fulfill that, and it's actually a profit center. I would say most of the time the engineering in a profit center is, I would say, kind of a level above cost centers. So think about IT type engineering. I don't want to dismiss them, but the scope is a little bit different. So we're seeing an increase there, kind of, I would say, more advanced engineering mindset. This is an engineering mindset that's used at scale quite a bit. So they're used to big problems. A lot of data scientists are looking at this. The amount of data available is really interesting to start doing correlation and basically anomaly detections and so on. And they're used to a very high expectation. Azure has a 99.9% availability. So you take engineering mindset that has met that bar and you start applying them to security, things are going to change. We're feeling it, and I think the industry will start feeling it as well. Let's see how good we are on time. So there was a presentation about, I believe it was 2013, the third annual International Cybersecurity Conference that pretty much said the same as well. So I believe that was the CEO of EMC, where they say security model used to be reactive and they're more intelligence-driven now. Intelligent-driven security model, and sort of a shift in security practitioners where they say migrate to big data control, a lot of data scientist skills. Even when we presented 2 years ago, I brought somebody from machine learning with me who's actually looking at how to bypass machine learning detection, but also how to use machine learning to actually go do offense, which was kind of interesting. And a lot of external threat intel. So we're not the only ones saying this. This is really good presentation. I would say the market is moving in whatever that person, I forgot his name, unfortunately. He's actually, executive chairman of RSA. But it's a really good presentation, gives you kind of a heads up of what's coming up. The assume reach mindset in the engineering is a little bit different. We used to think about security in terms of protect only. Oh, let's protect overflow and so on and so forth. But the reality is you have to do protect, detect, and response. So that changes the engineering mindset a little bit where we're shifting away from, okay, let's just build this huge wall. Let's assume the wall will fail. What we know about it and can we recover from it? Very similar to fault modeling approach, but now being applied in security. So the idea is that as you have friction with the environment, you should actually at least have a signal. Now, do you listen to that signal is the next step. But people are starting to really adding a lot of, not necessarily auditing, but signals. Oh, something happened here. Let's take a look at it. And I would say, from our perspective, we're starting to get caught more and more with those little tiny investments in certain APIs. Oh, there's like malformed data there. So the idea is that as the attacker is moving, they might be able to move, but they actually they ring a little bell left and right, and it's really up to you to go gather those bells. So I forgot who made that picture. I'd like to give credit to it, but I couldn't find who did it. This didn't come from me. I thought that was a really good representation of sort of our experience in assume breach. Let's talk briefly about countermeasures. I think I have a couple of minutes. So how do you counter that? How do you counter those trends? And earlier in the presentation, I talked about next-gen APT. So this is a little bit more detail here. So traditional APT, from our perspective, we see it as good targeting, effective recon, a lot of tool practice, advanced persistence, social engineering, somewhat sophisticated planning. That's been going on for quite some time. A lot of people believe APT kind of operates at that level. What we're trying to operate it at, and what we're kind of already seeing and anticipating more and more, is more of a really intelligence-driven, applying machine learning to the process, both from an offense and defense. Very persistence. Basically, don't give out don't look the same every time you go compromise, because you'll get your fingers pointed at you. So vary your persistence up to even emulating other attackers. We're seeing this in the quote-unquote public sector. We're starting to see it in private as well. Diversions. I love playing this game. It's a little bit challenging in enterprise. Start creating diversions. So you compromise an infrastructure, give out all the creds online. It says, oh, here's free creds. Now you have to deal with basically a whack-a-mole while you're navigating through the network, because all the kids are going to come in and start creating noise, right? So diversionary tactics is really effective. You're going to really piss off your blue team if you start doing this at a red team, but I think it starts a good conversation. Multi-front attack, really look at all attacks. So we're looking at not just physical, not just computers, cell phones, and so on. So start basically doing a multi-front attack, confuse the blue teamer as much as possible, and also confuse the machine learning that's behind it. Don't get me wrong, we're starting the anomaly detection. It doesn't mean it's solid, right? So start playing different tactics with them, confuse the system a little bit, and start looking at how can we actually fool the machine learning behind the detection. It can be a pretty fun game. We dive into it a little bit, as I said, in 2015. That's the link. Infiltrate is always really good at kind of giving out all the videos from the presentation. So if you want to dive a little bit more on that, go see the video. Also, speed kills. You may have a desire to persist, right? Red teaming, sometimes we want to persist, it depends, but speed kills. So automate your decision loop. Really go fast. If you go really fast, they're not going to catch up to you. You can do smash and grab operation all day. So if you're operating faster than they replicate logs, you're free. Now, assume you're going to get caught, but just go get to your target as fast as possible and walk away, right? So automate your decision loop. Do it at scale. So I'm kind of providing an ODA loop kind of structure there, where we call those smash operation is when we fully weaponize a particular TTP and we apply our decision loop there, then we call those smash operation. We just take everybody down with it. So that really forced kind of the needle in terms of pushing the blue team quite a bit. So it goes back to operate fast, operate really fast. So that's one of our countermeasures. We'll deep dive a little bit more, maybe in the next few years, where we'll provide a little bit more information. But I think we're good on time. That's it for me.